Thank you very much for coming. I'm very happy to be here, except for the audience's program count by weakers. But anyway, I will begin. Okay, I'm Shungo Adachi, a researcher in Toll Natsumed Laboratory at the National Institute of Advanced Industrial Science and Technology, or AIST. Okay, I'm here all the way from Japan with the help of funding from Wako Pure Chemical Industries. Wako Pure Chemical Industries is a leading company providing laboratory chemistry, reagent, and diagnostic reagent in Japan. And so I'd like to extend a big thank you to Wako Pure Chemicals. Okay, I will talk about our laboratory. Our laboratory has developing a proteomic method and has especially focused on protein-protein interactions. The aim of my research has been to develop useful methods for RNA research here, and I have developed a method to investigate RNA protein interactions. Okay, today I will talk about two topics. First, I want to introduce you to a method named iSlim. iSlim is a proteomic method for identification of important regulator of our specific RNA in vitro. And then I want to introduce to you a new product from Wako, mag capture tamavisin to livers, or just say tamavisin magnetic beads. You can use this product to purify biochelated RNA with very low background. Okay, now for the first part of my talk. As you know, the regulation of RNA, including stability, translation, and localization, is very important and involved in many RNA binding proteins. So to note these important processes, it is very important to know the interaction between RNA and RNA binding proteins. If you are interested in RNA binding protein, there is very good method called cross-link and immunoprecipitation, or CLIP. However, if you are interested in the specific RNA itself, you cannot use CLIP method, and specific RNA should be purified with its binding proteins. And the binding proteins should be identified using a mass spec. However, this approach is still very difficult, and for this approach, if we could develop a systematic method for this approach, would be very useful. So therefore, I tried to develop a method to identify important regulator of a specific RNA in vitro. Okay, first we used biochain-labeled RNA and streptavidin beads here to purify RNA binding protein. We used 7-scale RNA as a validation control because 7-scale RNA is a very well-known RNA binding protein, and 5 important binding proteins are already known. We prepared biochelated RNA and sterilized it. We performed purification using streptavidin, and finally we identified protein using mass spec. However, unfortunately, only lab7 of these 5 important binding protein was constantly identified. It's very sad data. However, we soon find a reason and a solution. We, of course, used to analyze the MOX control samples. This chart indicated that this chart is identified number of identified peptides in each samples. Okay, number of identified peptides in MOC and 7-scale pull-down sample is almost same, indicating that almost all the identified proteins was derived from MOC background. And in our laboratory, we usually use Frank peptide and drug antibody-based protein complex purification system, and it works very well. And this were indicated that the background of drug antibody is very nice. So I tried to use this drug system to RNA purification. We prepared in vitro transcribed RNA here and conjugated drug peptide to 3' end of the RNA. This is the chemistry of the reaction. And this reaction is very efficient here. So we then prepared drug conjugated 7-SK RNA again and performed the immunoprecipitation followed by mass spec analysis. This is a list of identified peptide proteins. Okay, we could identify all 5 important interacting proteins here, along with more than 150 proteins. It's not only the case of 7-SK RNA. For any RNA we used, we always identified more than 150 proteins. It is impossible to identify unknown regulator from more than 150 proteins. However, we also found that this important 7-SK RNA binding protein was only identified when we used 7-SK RNA as a bait. And if we use other RNA as a bait, here, we have never identified these proteins. And about other proteins, we always identify these proteins. In any case, indicating that if I use several beta RNA as a control, probably we can identify unknown important regulators. So we tried to identify unknown regulator using LDL messenger RNA as a model. LDL messenger RNA is a very unstable messenger RNA, and it is also known that PMA ARC-mediated pathway activation stabilizes the LDL messenger RNA. However, critical regulator of this regulation X is not identified yet. We hypothesized that critical regulator X interacts specifically with the LDL messenger RNA and does not interact with stable messenger RNA or unstable messenger RNA. However, that is not stabilized by PMA. We then selected 7 RNA as a bait, including LDL messenger RNA and other 5 stable messenger RNA and chimic messenger RNA. Chimic messenger RNA is a very unstable messenger RNA, however, it is not stabilized by PMA. We prepared 7 frag-tagged RNA and performed immunoprecipitation and followed by mass spec analysis. This is heat map of identified proteins. We performed quadruplicated experiment and identified proteins are listed here. And we extracted the LDL messenger RNA specific binding protein, and fortunately, we only find GFP36L1 and L2 as well proteins that specifically interact with the LDL messenger RNA. And we confirmed the result by Western blotting here. And this result was very encouraging for me because these proteins are known as RNA destabilization proteins. And however, and these proteins destabilize their target messenger RNA by recruiting CCR4 not poly-A deadenase. However, whether these proteins really destabilizing LDL messenger RNA or these proteins are inhibited by PMA ARC pathway is not known yet. So we checked both. To examine whether GFP36L1 and L2 are LDL messenger RNA destabilizing protein, we use the siRNA of this protein. We performed the siRNA and examined the stability of LDL messenger RNA using the actinomycin D chase assay. We performed the actinomycin chase assay, and as we mentioned, LDL messenger RNA is very unstable messenger RNA. And siRNA of this protein clearly stabilized LDR messenger RNA. And also, the protein was clearly increased depending on the siRNA of GFP36L1, L2. These results indicated that GFP36L1 and L2 is an important regulator of LDR protein levels. And also, these proteins are LDLR messenger RNA destabilizing proteins. And next, we examine the possibility that GFP36L1 and L2 is inhibited by PMA-ARC pathway. We speculated that GFP36L1 and L2 is phosphorylated by PMA-ARC pathway because this signal pathway is very famous kinase cascade. Today, I will not explain in detail, and just explain 4 results. Okay, first, I found that C-terminal end of GFP36L1 and L2 are phosphorylated by ARC pathway we found using the mass spec. And this phosphorylation of this protein caused the dissociation of GFP36L1, L2, and CCR0 polyideadenase. And 3, dissociation of CCR4 polyideadenase causes the stabilization of LDR messenger RNA. And finally, we found that the kinase directly phosphorylates this protein was RSK. So, GFP36L1 and L2 is inhibited by PMA-ARC and RSK pathway. These results indicated that GFP36L1 and L2 are exactly a protein I wanted to identify. So, these findings show that our method is very useful. Okay, this is a summary of iSpring method. By using low background IP system and several control RNA and reproducible mass system, using these systems, we can identify critical regulator even in vitro. And in addition to investigating 7-SK-RNA and LDR messenger RNA, we have performed many IP experiments and found that we can identify many other interesting RNA and RNA binding proteins using our method, including these well-known proteins and unknown several proteins. Sorry. Okay. And of course, we know that our method have critical limitations. We cannot identify the interactions that need cellular enzymatic reactions. For example, I cannot identify EJC complex protein complex as the interacting proteins. This protein needs splicing reactions. And also, I cannot detect the methylated RNA binding proteins, of course, which also need a methylation reaction. Sorry. Okay. And now no one knows 5% of all RNA and RBP interaction we can identify using iSpring, and 5% we cannot. However, we performed many RNA-IP experiments, and I think now I'm optimistic that probably I can identify more RNA protein interactions than probably I and other people expect. Okay, furthermore, I think that our limitation of our method offer potential for future development of our method. We have a lot of in vitro data here, and by comparing in vitro data with oligo-DT purified protein, it's in vivo data, and indicating that by comparing, we can identify the proteins that interact with RNA only in vivo. Okay, we performed this experiment and we found many proteins are categorized as an in vivo specific binding protein. And of course, EJC complex proteins are included in these categories. And the second is combined with enzymatic reactions. As I mentioned, we cannot identify the interaction of methylated RNA binding protein. However, interestingly, we can identify several methylase enzymes as certain RNA-specific binding proteins. So, if we combine the enzymatic method with isolate, of course, we can identify methylation-binding proteins. These results indicate that we think we can go forward step by step. Okay, now I will introduce you a new product from Wako, Tamabijin magnetic beads. Tamabijin is originally isolated from Tamogitake mushroom and as a biotin binding proteins. Most important feature of Tamabijin magnetic beads is shown here. Okay, we performed the mock pull-down experiment of streptabijin and tamabijin, and background binding proteins was visualized by silver staining here, and it's very clear that background of tamabijin is very low. We listed the features of tamabijin and streptabijin here, and background and tamabijin is much better, and binding strength both enough strong. Elution, we can elute tamabijin from tamabijin beads using specialized biotin solution. And usability, both methods have magnetic beads are available in both systems. Okay, this result indicates that streptabijin is good and tamabijin is great. I will show two examples of tamabijin magnetic beads. We use the biotin-related RNA. Okay, biotin is 7sk RNA again, and we perform the pull-down and perform the mass spec analysis. And this is the result, and this is the number of identified peptides as mentioned. When we use streptabijin here, the mock sample and the 7sk pull-down sample is also almost same. And when we use tamabijin beads, the number is very different. It seems very nice. And as I expected, we identified all 5 important binding proteins when we use tamabijin plus 7sk biotin-related RNA. And we also used other RNA. Photoene RNA is a very famous RNA, encoding RNA, and known to interact with EGX2 protein. And these are silver staining data and Western blotting data. There are 2 important points. In hot air pull-down sample here, we could detect the EGX2 protein, either streptabijin or tamabijin beads. And in mock sample, when we used the streptabijin beads, we could detect the EGX2 signal here, and it was not the case of tamabijin here. So, needless to say, tamabijin is great. Okay, conclusions. Our method is very good, and I presented the poster ADD6, probably it's between the 419 and 420. And probably I will stand in front of the poster today. Okay, tamabijin is great. Wako Pure Chemical Industry is also presented that exhibits the booth in the poster session room. Please come there. Okay, I'm grateful to the people listed here, especially Dr. Hirose at Hokkaido University for his advice. And also grateful to Wako Pure Chemical Industries. Thank you very much for kind attention.